Okay, what if I told you that there's a hidden pattern, a secret language, baked into almost every set of numbers you can think of, from the lengths of rivers to your company's expense reports? Today, we're pulling back the curtain on a strange mathematical secret that can actually expose lies. It's called Benford's law.
You know, there's that old saying, mathematics do not lie. We trust numbers, right? We see them as objective, as this pure, unshakable source of truth.
But here's the thing, while the numbers themselves might be honest, the people using them, not always. So that leads to a much more interesting question. Can math actually spot a liar? And the answer, which is kind of mind-blowing, is yes, it absolutely can.
Our journey into this starts with a really counterintuitive idea. It turns out that the numbers that describe our world, things like financial data, population counts, scientific constants, they are not random at all. There is a strange, hidden order to them.
I mean, think about it for a second. If you just grabbed thousands of numbers from the real world, say from stock prices or city populations, your first instinct would be that the first digit, 1 through 9, would show up pretty evenly, right? About 11% of the time for each. But that's not what happens. Not even close. Reality has a huge bias towards the little guys.
And the story of this discovery, it doesn't begin in some high-tech computer lab. Nope. It starts with a simple, dusty, old book of logarithm tables and someone with a very, very sharp eye.
The first person to notice something was off was an astronomer named Simon Newcomb, way back in 1881. But the idea kind of sat on a shelf for over 50 years, until a physicist, Frank Benford, rediscovered it in 1938 and really brought it to the world's attention.
And his discovery was just beautiful in its simplicity. Benford just looked at his log tables and noticed the first few pages, the ones for numbers that start with the digit 1, were super worn out, way more than the pages for numbers starting with a 9. And he realized, wait a minute, this isn't a coincidence. It means people are looking up numbers that start with 1 way, way more often.
So, what did this all mean? Well, Benford got curious. He started testing everything, over 20,000 numbers from totally different data sets, and he kept finding the exact same weird pattern everywhere. This led him to formalize his discovery into what we now call the first-digit law.
So here's the law in a nutshell. Benford's law says that in almost any large set of naturally occurring data, we're talking stock prices, populations, physical constants, you name it, the first digit is way more likely to be small. The reason is all about growth. Think of it like this. For a number to grow from, say, 100 to 200, it has to increase by 100%. But to grow from 900 to 1,000, it only has to go up by about 11%. So numbers just end up spending a lot more time with a leading digit of 1. And when I say it's skewed, I mean it's really skewed. Look at this chart. The number 1 shows up as the first digit about 30% of the time. But then look at that drop-off. By the time you get to the number 9, it's showing up less than 5% of the time. It's not a gentle slope. It's like falling off a cliff.
Let me put that another way for you. The number 1 is over 6 times more likely to be the first digit in a natural set of data than the number 9. That's not a small statistical quirk. That is a massive, predictable bias woven right into the fabric of our numbers.
Okay, so a weird number pattern is interesting, is a cool piece of trivia. But here's where it goes from being a curiosity to being an incredibly powerful tool. This is where it becomes one of the world's most effective lie detectors. And here's the key to the whole thing. When people make up numbers, like when they're committing fraud, they try to make them look random. They'll sprinkle in some 3s, a few 5s, a bunch of 8s, trying to spread them out evenly. But in doing that, they completely violate the natural curve of Benford's law. Their fake data sticks out like a sore thumb.
And I'm not just talking theory here. This stuff works in the real world. When analysts went back and looked at the fraudulent financial reports from Enron, guess what? The numbers failed the Benford's test. Big time. Same thing with the economic data Greece submitted before joining the Eurozone. And the law has even been used to flag potential irregularities in election results.
So that all sounds pretty good, but does this law actually hold up in the wild, with today's super complex financial data? Well, let's put it to the test.
Okay, look at this. On the left, this is the S&P 500. It's often called the gold standard for this kind of test because the data set is so huge and diverse. Now, those gray bars, that's the theoretical curve from Benford's law. And the dark blue bars, that's the actual data from the S&P 500 stock prices. I mean, come on, it's an almost perfect match. That is what clean data looks like.
And hey, this isn't just a US thing. This chart here shows data from the West African Regional Stock Exchange. And even if you don't read French, the picture tells the whole story.
The dark blue bars, the real data, are hugging that light gray line of Benford's law almost perfectly. It's another powerful sign of a healthy, unmanipulated market.
So, after all of this, what's the big takeaway? Why does this secret language of numbers really matter? Well, it's because every large set of natural data has its own unique signature.
I think the best way to think about it is this. The numbers have a digital fingerprint. Benford's law basically describes what the fingerprint of authentic data should look like. And if you know how to read that fingerprint, well, then you, or auditors, or journalists, can check for transparency and spot when something just isn't right.
So, there you have it. From a dusty old book to a powerful forensic tool against fraud, Benford's law shows us this hidden order in the world all around us. So now I've got a question for you. Now that you know the secret, what numbers are you going to look at differently?